Okay, so today we talked about the greatest common factor. We did not go into a lot of detail, but when we get into the bigger numbers, you're going to need to know how to find the greatest common factor so that you're not dividing and having to do it again and again and again. So we're going to take some fairly large numbers. We're going to take 108 and let's say 54. They're not very common, but what we can do is do the prime factorization tree of each number. So 108, off the top of my head, I don't know what goes in there. You can use your divisibility rules. I know all of these add up to 9. 1 plus 0 plus 8 gives you 9, so I know 3 goes in there. So I'm going to go ahead and start off with a 3. And you can actually be using your calculator for some of these chicken scratches off on the side. So it's 3 times 36. I'm going to bring the 3 down. I know that 36 is 4 times 9. Bring the 3 down. 4 breaks into 2 times 2. And the 9 breaks down to 3 times 3. So I have 108 breaks down to 2 times 2 times 3 times 3 times 3. When I do the same thing to 54, it's 6 times 9, which gives me 2 times 3. Sorry, that's my clock. And 3 times 3. So 54, notice I'm going to try to line them up, is 2 times 3 times 3 times 3. Then you circle your pairs. What do they have in common? They both have a 2, and they both have a pair of 3's, and another pair of 3's, and another pair of 3's. So you take one number from each pair, and then multiply them together. So I have 6 times 9 gives me 54. So with this one, 54 would be the greatest common factor. If we are including variables in there, so let's pick some a little bit smaller numbers. 64, x to the 4th, y to the 3rd, and 48 x squared y. So if I have those two and I'm going to do the prime factorization or figure out what their greatest common factor is, 64 I know is 8 times 8, and each 8 breaks down to 2 times 2 times 2, and another 2 times 2 times 2. I'm going to ignore the variables for a minute. 48 is 6 times 8, which is 2 times 3, and then 8 again is 3 more 2's. So I'm going to kind of show you a little bit of a shortcut. I have a pair of 2's, no 3's, then I have another pair of 2's, another pair of 2's, and another pair of 2's. It's just the same thing without me having to rewrite everything. So I have a pair of 2's. I have 1, 2, 3, 4 pairs of 2's. Remember, I take one out from each pair, multiply them together. There's a 4 and a 4 gives me a 16. So they have 16 in common for numbers. Now let's look at the x's and the y's. So for x's, this one has 4 x's. This one has 2 x's. So they have 2 of them in common, which gives me x squared. Another way you can look at this is that if they all have it, this has 4 of them, this has 2 of them, you take the smallest exponent out. Let's go on to the y's. This has y to the 3rd. This has 1y. So my GCF for these two terms would be 16 x squared y. If I were to ask you to factor 64 x to the 4th, y to the 3rd, plus, for example, 48 x squared y, I want to get rid of this little teeny dot here so it doesn't look like an exponent. So if I am asked to factor that, I gotta find my GCF, which is what I just found up here. I take out my GCF and figure out what I have left. So 64 divided by 16 is 4. I have 4 x's on top, 2 on the bottom. Leaves me 2. 3 y's on top, 1 y on the bottom. Leaves me 2 on the top. That should be a review from last unit. 48 divided by 16 is 3. They both have x squared, so those are gone. And they both have 1y, so those are gone. So I'm going to go back and figure out what stuff I have left. So 4x squared, y squared, plus 3. And the way that you check to see if this is correct is by going back and doing the distributive property. So 16 times 4 is 64. Yep, that's what I started with. X squared, I add the exponents, gives me x to the 4th. Understood 1 gives me y to the 3rd. Plus 48. Now notice I'm out of variables here. You can't just leave these hanging. They have to come with it because it's all of this times 3. So you're going to have to bring the x squared and the y along for the ride. So this is what it would look like if I asked you to factor it. By definition of factor, it means I have something times something else. So the factors of 12 might be 2 times 6. Or the factors of 12 might be 3 times 4, for example. So when you see the word factoring, you should be thinking multiplication.